If you've used Gimkit before, you know it excels at turning quizzes and vocabulary practice into games, letting you drop a set of questions into one of its many video game modes. Now with Gimkit Creative, you're no longer limited by the games that Gimkit has created for you. Instead, you have all the tools that they use to make those games so that you can make your own games. This creates all kinds of learning opportunities. It's a great way to explore systems thinking, for example, to create a functioning game. It's also an engaging new way to approach the computational thinking concept area of the New York State Computer Science and Digital Fluency Standards. These are typically viewed as the coding standards, but Gimkit Creative is not coding. It requires no previous coding knowledge, but instead gives you an intuitive space to develop computational thinking skills without being excluded by the language of coding. Let's look at an example of this. So I'm in the Gimkit Creative platform, and this is just my sandbox area, so there's stuff everywhere. But looking specifically at the Computer Science and Digital Fluency Standards computational thinking concept area, we have a bunch of standards that seem like they can only be accomplished by teaching coding. But let's look at this first example. Looking in the grade 4 to 6th grade band, develop a computational model of a system that shows changes in output when there are changes in inputs. Now, to give you an example of what that might look like in coding, we can do that pretty quickly on Scratch, right? We have an input here, or an event. When this sprite is clicked, move 10 steps. So we have an input and we have an output. And when we use that input, we can see the output. We can track the changes in output based on changes in input. In Gimkit, we can accomplish that same task. So let's use one of our many devices, right? Create game mechanics with these devices in Gimkit. These are the building blocks of your Gimkit game. We can use maybe a button to be our input. So whenever a player pushes this button, something can happen. And just to kind of see that visually, let's use a counter device, which just keeps track of how many times things have been done. All right, so we have an input and we have an output. We can connect those together a couple different ways. I'm going to use a wire. So when I click my wire option, I can see that I can connect it from the button to the counter. And now I have an if-then statement. It's not structured the same way that you might see in Scratch, where we really just have an if-then block, right? And then we can start to fill in the different coding language to go with that. But if the button is pressed, or when the button is pressed, an action takes place. We can increment the counter, make it go up. We can make the counter go down. We can reset the counter. We have options. So we have an input, and we choose our output. So now, if I were to play test this game and go and find that option, it's a little bit higher here, right here. I interact with that button, and my counter goes up. I have an input, I have an output. I can track changes in the output based on changes in the input. So that's a pretty simple example of a functioning model for tracking inputs and outputs. And obviously, that gets more complicated the more sophisticated your game becomes. You could create a digital escape room where when players interact with buttons in a certain order, some kind of information or new room is revealed in the game, right? We can track inputs and outputs and how they impact each other. Going back to the standards document, we could really accomplish any of these standards. We could meet these standards in meaningful ways by getting creative in this platform. Another example, looking at identifying pieces of information that might change as a program or process runs. We're kind of seeing that in action based on the first standard as well, right? We can update that information, that data that's being tracked even, for example, this counter, based on those inputs. Comparing two or more algorithms and discussing the advantages and disadvantages of each for a specific task. So we can do something very similar in Gimkit Creative, because algorithms are really just sets of instructions, and that's what we're doing when we start to edit or play with these game mechanics. So I connected this button, this input, to this counter, this output, with a wire. I could also use a channel. A channel is like a broadcasted message. So it can be received by any device, right? Whereas with a wire, I'm going from point A to point B. So let's say we create a channel called go up, and when the button is pressed, that message, that channel, is broadcast. Then we can go over to our counter, and we could say increment counter when receiving on go up. Now I can get rid of this wire, but because I have that channel set up, I can still, if I go back to playtests, find my spot, interact with that button, and impact that counter. And that channel that I used to broadcast a message from button to counter could be used for other things as well. So going back to our standard where we compare two or more algorithms or sets of instructions, we could talk about the advantages and disadvantages of using a channel compared to a wire, and the limitations of the wire, the complications of the channel, all of that juicy conversation that we could have in developing these games. We can continue, any of these standards can really be met using Gimkit Creative, explaining each step of an algorithm. That includes repetition and conditionals. If we go back to Gimkit, we can see great examples of repetition and conditionals. We have a repeater device that can help us repeat any task, and we can control how that task is repeated. We can say the task is repeated in seconds, 5-second intervals, whatever we want. We can stop the strategy after a certain amount of time, after a number of repetitions, or after receiving on a channel. So that could be compared to Scratch, where we have a block that says repeat until, right? And the until in this case would be when they receive that channel. So something else in the game could cause that repetition to stop. So this is a great example of using repetition as a strategy in computational thinking. And thinking about conditional, we had that if-then statement that we saw with the wire. We could take that further with a checker device. So a checker device will only trigger once conditions are met. And we can have up to 4 conditions in the same checker device, or 5 conditions, 5 checks. So we can control the conditions of the game using a device like this, so that only what we want to happen happens when certain conditions are met. So Gimkit Creative doesn't require direct coding knowledge or a functioning understanding of the coding language, but lets students play with these computational thinking skills as they create a fun and engaging game that they can play with their peers.